Next, we're going to take some exponential functions, we're going to graph them, and then we're going to explore the domain and range for each of these. We're going to start with this one, and if you recall from our last video, our exponential function f of x equals a times b to the x. Last time we called this y, but f of x is just a name for y. A is our y-intercept, b is our multiple, and x is our x value. So if I wanted, I could plug in some x values to get this. So let's do that. X and y. We get, let's do 0, 1, and 2. And we'll see the pattern show up quickly. So if I plug in a 0, I get 4 times 3 to the 0. Now, anything raised to the 0 power is 1. So we get 4 times 1, which is just 4. All right, let's plug in a 1 now for our x value. That's 4 times 3 to the first power. 3 to the first power is just 3, so that's 4 times 3, which is 12. And then next we have 4 times 3 to the second power, where our x is 2. 3 to the second power is 9, so that gives us 4 times 9, which is 36. All righty. So let's graph a few of those. We get 0, 4, 1, 12. So 0, 4, 1, 12, and the next is off my graph, but I want to show the pattern right here. So we can see from here to here we're multiplying by 3, from here to here we're multiplying by 3, and then going the other direction, if I went into negative numbers, that's just the opposite of multiplication, so we're going to divide by 3. So we'd have 4/3, and then 4/9. If I wanted to keep going, let's go ahead and think about what that looks like on the graph. So as we multiply by 3 going this direction, we're going to get steeper and steeper because multiplying by 3 is going to get 3 times as tall each time. If we divide by 3, well, 4 divided by 3, that's going to be 4/3. Then we're going to divide that by 3. Then we're going to divide that by 3, divide that by 3. And again, we're getting closer and closer to 0, but we never actually reach 0. We can see this curve show up, the exponential curve. Every exponential function is going to have this same basic shape with our asymptote on one side and the other side gets steeper and steeper. So let's think about our domain. We're going to go forever in that direction. We can continue to divide numbers by 3. They're going to get very, very small, but we can still divide them by 3. We can go forever in this direction because we can always multiply a number by 3. It's going to get very, very large, but we can still multiply it by 3. So our domain, our x values, go forever in that direction and forever in that direction. So like we saw in our last video, the domain is all real numbers. The range goes from 0, our smallest y value, all the way up to infinity. So we're going to be 0 to infinity, like we saw in the last video as well. So that would be 0 is less than, y is less than infinity. Okay, let's take a look at our next one. Now this one I'm not going to do a table of values, although if you want to, you can. I'm just going to look at my y-intercept and I'm going to look at my multiple and I'm going to think about what that happens to the graph. So our y-intercept is -2. Let's go ahead and put that on the graph. Y-intercept is -2. And our multiple is 5. So if I multiply -2 by 5, that's going to give me -10. And then it's going to give me -50 way down here. If I go the other direction, I'm going to divide by 5. Well, that would give me 2/5 and then 2/25. And again, we're getting very, very close to 0. So we can see our exponential curve show up, but this time it's upside down. Well, let's think about what that does for our domain and range. Again, the domain goes forever in that direction, forever in that direction. So it is still all real numbers. And I want to reiterate that the domain is always going to be all real numbers because we can always continue to divide or multiply. And our range in this case is going to be a little different. So we notice that we go down all the way to -infinity. We're going to go down as far as we can, but we go up and up and up. And our asymptote is again at 0, but the 0 is our top value. So our range is going to go all the way down to -infinity, and it stops at 0, and our y values between those, it never reaches either, so it's going to be -infinity is less than y, is less than 0. Let's take a look at one more right here. We spot that our y-intercept is 10 and our multiple is 0.5. If we multiply a number by 0.5, that cuts it in half. That's the same thing as multiplying by 1/2, so you might think of it this way. All right, let's take a look at what that does to the graph. So our y-intercept is 10. If I multiply that by 1/2, I get 5. Then I get 2.5. Multiply that by 1/2, by 1/2, 1/2, 1/2, and we can see that we're getting closer and closer to 0. Going the other direction, that would be, instead of multiplying by 1/2, that would be like multiplying by 2, so it's going to be 20, and we get steep over in this direction, and we're going to have our asymptote over to the right side this time. Same shape, but now it's flipped around the other direction. If you ever need, you can just do a table of values and put some values on here to help keep things organized if that's helpful for you. So our domain, again, is going to be all real numbers. We go forever in this direction. We can always cut something in half or multiply by 1/2. We go forever in that direction because we can always multiply by 2. So all real numbers. Our range this time goes from 0 again all the way to positive infinity. So from 0 to infinity, that's our y values. So 0 is less than y is less than infinity. Now, they're all going to be very similar to this. They might be flipped upside down. They might be turned around backwards. Just think about the pattern. Think about the y-intercept. If you need to, you can plug some values in and do tables of values. Being able to evaluate this is important. If you're ever going to do something on the calculator like 4 times 3 to the 10th power, that's a tough one to do by hand because that's very large. You can just type in 4 times 3 and then the caret button on the calculator is your exponent. So that will help you to generate tables of values and plug in some things like that. Thank you.